David, you are a long-term supporter of the multi-world interpretation of the
Yes.
Schrodinger equation that governs the wave function of the quantum mechanical systems. Are these splitting off worlds infinite in number? We'll start simple.
Oh, it's not known, and it doesn't make much difference to the theory whether they are or not. But I think the infinities you were talking about, the cosmological ones, they're different from the quantum mechanical
Yes.
universes. The universes that are invoked in cosmology are universes with different laws of physics and so on. And there is a genuine problem. If there's an infinite number of them, there's a genuine problem that means that no predictions can be made about them, because if they're all equally likely, that doesn't mean anything, because then each of their probabilities is zero, strictly zero. So that's completely different from the quantum mechanical universes proposed by Hugh Everett and by Schrodinger, by the way, which I think there is incontrovertible evidence for, and which precisely do not have this measure problem. So if the cosmological infinity is to be tamed, some way of solving the measure problem for them has to be appended to the existing theories. Of course, if there's a finite number of them, like 10 to the 500, then there's still an issue. There's still an issue of whether the number should be regarded as a probability. I think not.
Okay, there are many questions that one have. I do understand the multi-world interpretation is theoretically the only interpretation that doesn't interpret the Schrodinger equation. It just takes it at face value and doesn't have to go through any type of a decoherence or anything else. We'll get to that. But I still want to press you on this. Is the number infinite, or is it just so many gazillions that that you don't know? Can you give an answer to that?
Well, I think it's not known.
It could be. It could be infinite.
Number,
it could be. It literally
could easily be infinite. The number of distinguishable universes is more likely to be discrete, but it could still be a discrete infinity, like the infinity of the integers, rather than a continuous infinity. But we don't know in either.
And would that be an infinity in both temporal directions, backward and forward? I'm asking maybe naive questions, but these come to mind when I hear about the multi-world.
No, it's not naive. Now you're raising the question to involve quantum gravity as well, because different times are special cases of different universes. But what that means in a specific theory, we just don't know. That would require a theory which unified general relativity and quantum mechanics, and we don't have a satisfactory one of those. So,
sure.
Sorry, I don't know. I would tell you if I did.
No, I know you do. You're not bashful with your ideas. That we know for sure.